Welcome, everyone. I'm JD Graham, the Outreach and Engagement Specialist at the Midwest Big Data Innovation Hub, and this is our June 2024 edition of the Data Science Student Group webinar series. But before I normally introduce the episode and our guests, I kind of want to take a moment and reflect because today marks the final episode of our series, capping off a really great run with a total of 24 episodes over the past 6 years. John, did you have some things you wanted to say as well about that run?
Yeah, thanks, JD. As you said, this is at the moment our last scheduled webinar in this series, which began back in 2018. And so really, this has been a fantastic way to help students understand data science and the roles that they may be able to play in it going forward, either as students or as professionals. We've had some great guests over the years and some great hosts as well. I see one prior host, Elise Delage, on the call today. Melissa Cragen as well was a founder of this series back in 2018. And so I just want to recognize their contributions to this series and their advocacy of student engagement in the hub. We do plan to continue working with students and student groups going forward, in particular continuing our student group profile series on our blog. And so if you are a student group leader or a faculty mentor, feel free to reach out to us and we'd be happy to talk about including you in that series, looking at best practices for student groups. So that's all I really wanted to say. Welcome to our panel today. We're really excited to have this conversation with you today. And so I'll turn it back to JD to get us started on our topic for today.
Thanks, John. I really appreciate that. It does really recognize all the people and the hard work that's been put into this. And I know for me, it's an honor to be able to continue the tradition, to fill in for big shoes and put my feet in there. And that fits well today for our Muddy Boots discussion. But before we continue the metaphor and start wading in the murky waters of messy field data, I do want to talk a little bit about what our program is before we begin. We are a regional organization funded by the National Science Foundation, working with a 12-state area in the Midwest of the US. But we're also part of a national network of 4 hubs founded in 2015 to be a catalyst for connecting diverse groups across the country. We're focused on data science and data-related activities in academia, industry, government, and nonprofits. Building collaborations and partnerships between sectors is what the hub does. As I mentioned earlier, we bring together university science students, leaders from official RSAs, as well as informal organizations to share best practices, their experience in developing programmatic activities, and different ways of building local communities. Additionally, we have recruited speakers to talk on a variety of subjects graduate and undergraduate science students care about. Our goal is to learn from each other and to help build a network of student leaders across the region. The hub has this webinar series and profiles of student groups, and as John says, you can go to our site or YouTube and catch past performances or catch past webinars. So without further ado, though, I'd like to introduce our guests for today. Our first guest is Laurie Nowatzke. She is a coordinator for the USDA Midwest Climate Hub stationed in Ames, Iowa. Leif Olmanson. Leif is a water quality research scientist at the University of Minnesota in St. Paul. And our final guest is Sreya Vadapalli. She is a data science research associate at Rogers Behavioral Health. I'm going to try to get this right. It's in Wauwatosa, Wisconsin. So thanks for taking time to lend us your expertise, everyone. Let me get that off there. There, we should be able to see everyone. I'd like to start out with Sreya. You know, for you, what does messy data mean compared to clean, curated data? What are the differences between these two things? And then we can talk with everybody about, you know, how to deal with it. But I think we need to find out exactly what it is.
Firstly, thank you, Jay, and John for this incredible opportunity. I'm like super excited to do this. And you got my name. You got that right.
Oh,
I
good.
think for me, yeah. I think for me, like even if, like I started my career recently, and during my undergrad and like graduate studies, I was like actively involved in like these laboratory research data analysis, and it was more like a curated and like like a clean data. And over past like 8 to 9 months, my focus has shifted towards the working towards extensively with real world data, and in particularly in like in the realm of hospital and medical data. I think one of the most important thing between the significant difference is the way the nature and the structure of the data is between these two, and how and this kind of like presents unique challenges and like opportunities for like analysis and interpretation. For something uh, Defining a clean data would basically mean like simply refer to it as any information that is maybe accurate and like well organized and free of inaccuracies and errors. um, if we're like talking in terms of medical or like biotech data, we kind of let's say we're like evaluating some effect of some drug in some like for treating bacterial infections or something. You kind of take you take a set of patients, you control the environment, control these conditions. So everything, there's like a backstory to it. You're actually doing everything way before you're basically already doing the experiment before actually doing the experiment to get some certain kind of data. So it's like super well organized and all of that. And in terms of messy data, I think right now I'm dealing with a lot of hospital data, like medication hospital data. And I would say that hospitals, like second name is messy data. And because in hospital, let's say like we're doing something with electronic health records, I think uh, there's so much information for like a single patient, so much structured information, unstructured information, and like other random stuff in it, that it kind of makes it complicated. uh, I think then again I would define messy data something as a combination of structured and like unstructured data. But I think even though messy data is very hard to deal with, I think it has more insights to give, more insights to present to one. And anything that is easy is boring. So I think messy data is more fun to do handle, and like more, it has more insights.
Messy data can be exciting. That's a good way to put it because it does have a lot of variables and it isn't just doing the same thing every time. What's that look like for you, Nori? Laurie, what does that look like whenever you get messy data? Because I think it's going to be different for each one of you. I mean, we have different sectors we're working in, and I think it's going to have like take a little different shade for each person. So, Laurie, what's that look like for you, and what kind of challenges does it present?
Yeah, thanks, JD. That's a great question. And it's funny, it's different for all of us, I'm sure. But as Sreya was talking, it was jogging some memories of like kind of really similar experiences I had to what she's describing. So for just a bit of background, I'm a sociologist, so I generally deal with human subject data, whether that's in the form of like large scale social surveys or also kind of smaller scale qualitative data collection through focus groups or interviews. And so those kind of inherently come in different formats and structure. But looking back, in previous roles I've had, in my previous position at Iowa State University, I was working with trying to understand how conservation practices are adopted throughout the agricultural landscape in Iowa. And we relied really heavily, similar to the hospital experience, we relied really heavily on data that was collected through administrative processes. So what I found is that I think messy data also can be sort of defined by how many people are collecting the data, and sort of the more people you have collecting the data, the messier it probably gets, and the more likelihood of human error with certain entries or inconsistent units or missing data entries. And so we worked really heavily with data through sort of our state agencies and federal agencies that provide loans and funding to farmers to try out different conservation practices on their farms. So there are these vast databases full of information about specific conservation practices that received funding through public sources. And like Sreya's example, you know, these were entered by practitioners in different county offices for different agencies, or agricultural advisors. And so the more people you have with hands in how to enter the data, the more difficult it is to get sort of standardized data across the board. By contrast, when I work with social survey data, I consider that so clean because it's all really predefined by how we structure the survey to begin with. You know, the better you write the survey at the start, the more control you have over what the output or, you know, the final data set looks like. And it can be very structured. It's about specific options. And you might have some open text options, but they're really defined by the question that you present. And so, so to me, it's kind of that. It's like, to what extent are you relying on lots of different data collectors who are inputting data into an existing database versus something that's a little more has bounds around it, like a specific data collection effort that might involve just a few researchers. Even if you're pulling data from lots of different humans and people, it can be messy in its own ways, but at least it's structured, kind of to Shreya's point. So
yeah, and I can imagine it also has
fun.
different formats, right? Different formats that you're getting from these different sources. So I mean, it's really easy to think that when humans are involved, it's going to get messy. But if you get to design it and you get one source, it doesn't have to be quite as messy as opposed to many different types of sources, and you're trying to pool them into something you can analyze. What do you find, Leif, with that as well? Because again, we take a different direction with you with remote sensing and water quality. How does that look? How does messy data look to you, and what makes it messy? Oh, Leif, you're muted.
So yeah, so for Minnesota, we have the state agency that organizes data from the state, and it's worked pretty good for over the years. We have for the way data is collected, works good. But lately I've been going outside of Minnesota, so I've been working with other states and other groups and coming up with lots of different kinds of data and finding quite a variety of different things. For like Minnesota, we have the agencies do a small number, like about 100 lakes that they'll monitor on a regular basis. Volunteers, there's a field for lake water quality monitoring. Most of the data, 90% of the data, is actually collected by volunteers. So lots of different groups and lots of different expertise, and not organized very well. Not necessarily organized very well. In Minnesota, they actually have a program where they do some training and trying to get things pretty consistent. But then they don't really do a lot. That's more for just like the Secchi disc measurements, was a fairly simple. You're putting a disc into the water, see how clear the water is, and that's fairly straightforward. But for like chlorophyll, a lot of the big lake associations will actually have coalitions of lake associations that'll actually organize these things. So that seems to work pretty well because they'll all be kind of doing the same thing at the same time, organizing the collections and then pick up the samples, get them off to the lab. But it is, the volunteers, it's basically volunteer data is the big bulk of data in Minnesota. For other states, similar, but we're looking like Secchi disc is a fairly straightforward thing because it's a disc. But we're even finding out, I'm working with some people in Cape Cod, and they actually use a view scope to get their Secchi disc reading, which is a different measurement than a regular Secchi disc. So we're doing some comparisons to do, to make sure what's going on when you're doing these different methods. The big thing I've been running into lately, because we've been doing, like 5 or 6 different states, and chlorophyll is a measurement that's commonly used for lakes. but it's done different. There's no standard way of doing it everywhere. And so you have different ways of collecting it. Some will just collect a grab sample. Some will do a integrated over a certain, maybe 1 to 3 feet, 1 to 6 feet. Some will be the whole clarity. If it's really clear water, you'll do a really long integration. So it could be 20 feet, 25 feet integrated sample. Others, different ways of collecting the data for one thing, and then filtering the data, processing the data, and then analyzing the data are not always the same either. So there's lots of different variables, and we're just kind of starting to work with trying to figure out if we can figure out if there's any bias to any of these different methodologies to make sure we have a consistent data source when working with data from different states. Let's see. So the way I use data is basically I'm using it for calibration of remote sensing data. So I will take, we'll have like Minnesota, we may do 7% of lakes will be monitored any given year. And we'll take that data and we'll put it to the satellite imagery. We'll develop a model for the satellite imagery, and then we'll process all the images we have. And so we'll actually have many order magnitude more data from the satellite, which is more of a consistent way of doing it. But there are errors in remote sensing as well. So there's a lot of compounded errors in the field, plus compounded errors in the remote sensing with atmospheric effects.
And,
so there's lots of different things going on.
Yeah, being outside too. A lot of our students probably don't know what a Secchi disc is, but it's like a little, looks like a little plate, and it has black and white patterns on it, and you can measure, the clarity of the water by dipping it down till you can't see it any longer. I can imagine working with the public. It's bad enough that you have to work possibly with other professionals and how they do things, and how it seems. I'm going to, air quote again, standardized. But each agency, each place has their very particular way they're going to be doing it. But start to work with volunteers, and now it isn't just each agency has a specific way they're going to do it. We may almost be down to the granular. Each person has a different way they're doing it. And if you're a volunteer, maybe you're not a professional, you don't know maybe the units and the format at which you're going to collect it. I can imagine that gets really messy really fast. When you guys get messy data, like what's the first thing you do? Sreya, what's the first thing you do once you're going to get this messy data in? Do you have like things you look for right off, or is it, maybe a little bit of crying first? What's it look like?
I think it's crying followed by things to actually look for. But I think when I get, like personally, when I get messy data, I kind of like try to go back and read what I'm trying to actually get out of it. Because I think it's very like important to like actually like once you see the data, and then you'll have to like go back to why you're seeing the data, to like what kind of information you kind of want out of it. But I think for me personally, because medication like data has a lot of random like data in it, like a lot of mixed data in it. There's like random clinical notes from doctors that you can't really like discard, because it's equally important. Like a random scrub, like like a random scribble by the doctor is like equally important. You might like miss out on some information. So I think maybe trying to initially, I think I would try to like try to integrate all the different kinds of these kind of data, because we have data coming from the doctors, data coming from their outcomes, data coming from their questionnaires, and like all of that. So I would try to sit down and think of a way to like integrate all of it, and then try to think of methods and like other approaches to do it. But I would first think of just arranging the data, that would make sense to me and also make sense to other people. So I think I would try to focus that part.
Yeah, I can imagine if you're going to try to cooperate with other people as well, you have to have some sort of standardized way. You're going to say, hey, this is how we're going to share it. Where do we put all of that extra data? like scribbles and have it be able to be cross-referenced to something that's an actual piece of like numerical value that you can play with. Laurie, what do you find whenever you get that messy data? What's the first thing that's on your mind? How are you gonna approach this?
Yeah, this is a really interesting question because I'm not sure I've really thought this through really concretely. But as we talk, I think there are processes that we all sort of develop individually. And I like Shreya's point about, finding the structure, find a way to organize it, some common structure for the messy data. To me, that's really for those mixed data issues. I think that's a really key feature. Like, can you tabulate it? And if you did, what would it look like in a tabulated form? What are the variables that you're defining for each observation? If it's if it's a script or a note, what are that's one observation. What are the variables that are going to come out of that? Another thing that if it's already tabulated, I mentioned working with a lot of that administrative data from our state and federal agencies that may or may not match up and may have human errors. That's already tabulated. It comes out of a database. But the first thing I do in that case is to figure out, just look at descriptive statistics. I think if it's already tabulated in a way for you to look at it, look at what the ranges are. One example is with some of these data sets, we found that various farms throughout the state were adopting terraces, which is a really important water quality practice and soil conservation practice in the Midwest. And terraces kind of flatten out hill slopes and holds the soil back from sliding down the hill slope. And so, and from eroding. And we had data that suggested that, this farm has 1 foot of terrace, which is just not feasible. And then another one would say, I don't know, 600,000 feet of terrace, which also isn't feasible. So if you get the descriptive statistics, you can start to see the ranges and kind of block out what is reasonable, what are my outliers. And eventually I got to a point where, okay, you can identify the outliers that are likely driven by error in the data that's really driving that messiness. And you can start to assign some different estimated value, whether it's an average or a minimum or something for those outliers that are very clearly just human error or misunderstood units, things like that. So I think, we're always trying to get at some sort of consistency and structure. And that's kind of, to me, the first step is just what does it look like to begin with? And what can you glean from that?
I think, Laurie, you opened to a really great idea too, but not just like the first thing you do or how are you going to start to structure this. It really starts to get into the weeds of the techniques for cleaning and processing this messy data. I mean, you've got to have some statistical techniques. You've got to have some data wrangling cheat sheets almost of where you're going to go first, so you can start to make this look, well, as you say, reasonable. And Leif, what's that look like for you when it's like unreasonable data, when you're getting it from volunteers, you're getting it from different agencies now? What kind of techniques are you going to be using besides, I'm sure we're after you do this a while, you start to, I'm sure you could start to look at it and just have that feel like this looks a little off. But in the end, we have to have some standardized ways that we would approach that. Like, how are you going to actually clean this data up? Or at least how are you going to categorize it as usable or non-usable, possibly?
Well, luckily, there's a lot of the data sets I got are very clean already, which is very helpful. But the ones that have been a little bit messy, there's one in particular that was extremely messy, and it would have it would be used like for like SecuDisc would use feet and meters, and then I'd basically kind of start going through lake by lake and trying to figure out, because there'd be lakes that would have by feet and meters, but the value would be the same. So one of them was wrong. But by lining it up by time, by lake, you can actually see what's going on with this lake. Is it what units is it? It's pretty easy to figure it out that way, because the lake doesn't change rapidly. It's going to do seasonal changes, but it's not going to do go from one extreme to the next really quickly on the same day, the same time. So This
Yeah,
was
I've
the
seen
same
some data
similar
myself.
Yeah.
Leif, have you ever had the experience of having meters and inches in the same thing? Like, 0.2 meters, 3 inches. Like, what
Yep.
is,
Yep.
that must be a really big challenge there as well. But
Yep. Yeah,
statistically speaking, like, where do you start though? Like with those techniques, is it just seeing if it looks like reasonable data, or is there actual tests that you start off with to go, okay, let's look through this stuff?
well, my best test is actually linking up with satellite data, and the
Cross
satellite data
comparing.
is really fairly consistent, and so outliers stand out like a sore thumb. So I will be able to identify the outliers and then go into the data sets and say, hey, what's going on with this one, and identifying it that way. So that's the approach I'm doing. Because I trust the satellite data more than the field measurements sometimes.
Yeah, I could 100% understand that. Sreya, do you have a statistical techniques you're like your go-to, or do you have more of that feel that you have to start with to kind of separate out the good from the bad?
So I think like like there's definitely a lot of time put in. Like I said, like there's definitely a lot of time put in for arranging the data, and then after that, I try to look what are the outliers. Of course, I try to look for that. But I think in at least in medication, I mean in like hospital realm of like hospital data, I think outliers are really important because like when you're like for example when you're giving a drug to some patient and there are certain set of patients that are like acting as outliers and these drugs are not working on for them. I think those outliers are now taken for another whole study, like why they're not working. So that's a whole different study. I think in hospital or medication data, I think this kind of approach is more common because if some like if these certain set of patients are acting as outliers, there's something that's not working out for them. The experimentation has to be changed, or whether the way we're approaching those patients has to be changed. So that is something of real importance in medication data. But otherwise I think like dealing with there's again a lot of missing data and like inaccuracies that are often seen in medication data, whether a nurse might have wrongly inputted the vital sign, or like another doctor has like not written it down, like not written a prescription down well. So there's lots of things to deal with. And I think for clinical notes, when you're there's a lot of free, or like Laurie mentioned, free text options in questionnaires, and this would be relevant, this would be equivalent to like clinical notes or like prescription notes in medication data. And that is really hard to deal with because that's like literally like a long series of texts that are not even supported to be stored in a database. And even if they're stored in a database, it's very hard to like extract actual information out of them. And then we would probably use natural like natural processing languages to kind of get a meaningful information out of that. And like for missing data and other inaccuracies, I think it would be similar to other studies. There's nothing unique about it, just for medication data.
Shrey, how often do you get to be the person actually making the questionnaire data, or being involved with the people making the questionnaires so it's a little more usable, or do you not very often and you have to just deal with what you're being given with?
So that's actually an interesting point. For questionnaires, there are actually different kinds of questionnaires. One questionnaire would be just like already assigned. Like there are a set of questionnaires that we send out to mental health patients that are already fixed. That these are like already we've been already using like some like years and decades now. That we don't like no one really kind of changes them, like Ybox, for example, or like Promise Index, for example. So these are there's nothing that I do in that. We already send out those questionnaires, and then we just get information. But there are other set of questionnaires that is just implemented to see whether they like the, because in mental health, for mental health patients, the main priority is to like have the environment suitable for them. So we also keep checking if they like the environment that they're staying in, if when the patient is admitted, if they really like the environment that they're staying in, or do they need some changes, or like, so those kind of questionnaires can be changed a little bit. And we do have like all our, like the research department quite like does keep changing those questions. But the major like the outcome questionnaires is already fixed. It's like these questionnaires that have been used like for decades now. Yeah, so there's not that many changes. But because we're dealing with mental health patients, we need to understand that these questionnaires, even though they give us like actual results, it actually depends on the mood of the patient, and like the situation at that moment. So it's very important to see, to interpret the results based on that.
You mentioned really something interesting too about using large language models. How does that come into actually processing the data, and how much like are we relying on outside like a ChatGPT type of thing, or is it something internal that you are using? And like how reliable is that? Sreya,
So
I'll give it back to you on that one.
yeah. So I think for the natural language processing that we're talking, the first thing is like I mentioned, like the doctors have, like in the electronic records, the doctors have this unstructured clinical notes. So unstructured clinical notes are like really important to understand the doctor's perspective on the condition. So these like they have really like long texts, and this is something that if you want to understand what the doctor is, if it's like 2 or 3 patients, we could like manually extract it from the electronic like manually copy paste or like manually type in the electronic from the electronic health records. But if you're dealing with like hundreds and thousands of patients, I mean, no one has to do that. No one shouldn't do that manually. So that's where the natural language processing comes to just get the information out. Firstly, to extract the information, and then to get the like once, if you're saying that if the doctor, let's say if a doctor is saying, just writing and saying that positive, that there's a positive outcome, or there's negative outcome. So we use words like positive and negative and other relevant relevant words that are good to be picked up, and then we kind of implement this model. And so of course, as I think, as being in data science, to update myself, I use chat gpt a lot to just to stay updated, because there's hardly we can learn things from textbook now. So I think you need to keep it by keep trying out Google Gemini and ChatGPT, and then trying out these natural language processing models. But yeah, like you said, I definitely do go to ChatGPT whenever I'm stuck. But yeah, you can't like 100% rely on it. You have to make your own changes and get it out.
Well, Laurie, you talked about using also like survey data or questionnaire data. How does it look similar and different to what Sreya is saying, and how you deal with it? And if you've maybe used large language models to process that data?
That's a great question. And it's fascinating to hear Sreya talk about this, because I'd say it's different in a lot of ways. And I think the first big difference is scale. If Sreya is dealing with hundreds or thousands of patient records, we in social science data, we typically are dealing with, if we're talking about, actual human data, this looks different if you deal with like media data or something. But for data we're collecting from individuals, it's typically on the order of, for surveys, anywhere from a couple hundred to a few thousand individuals. I think the largest survey data that I've worked with was 6,000 respondents, and most of that was structured. It was specific questions and very quantitative. But when we want to understand either the open text responses, or we are collecting open text or kind of interview data, there are some really clear guidelines. So if anyone on the call isn't familiar, qualitative human research is has some really established analysis protocols. And so if anyone is interested in looking into this, kind of in how we can analyze the data before going into the kind of more modeled ways to analyze. But I would encourage folks to look into grounded theory or and encoding practices with text data or transcripts from interviews or focus groups. And that provides some really clear guidelines for how to deal with it, both in terms of the actual process of coding or kind of identifying themes and patterns that show up, and also in establishing validity and reliability. So you can have multiple people coding the same set of data so that you can get at some, and then if there's disagreement in how you interpret the data, then you have to broach that and try to understand why those differences or biases came up. It can be really challenging, and I think I used to think that statistical analysis and quantitative analysis with social survey data was more difficult, but in fact, like I've come to find that I'm more intimidated by the qualitative data analysis because of the potential for introducing your own bias as a researcher or dealing with that kind of messiness. But it takes a little practice. But then to their point about kind of naturalized language processing, I personally have not worked with it aside from using R scripts that can pull out specific phrases or something, but I think that's fascinating, and lots of opportunity there, especially in order to turn this into more of a big data approach, right? So like Sreya is talking about, just a bigger scale and understanding much larger data sets and unstructured data. So yeah, I think that's maybe a frontier in sociology, but it would probably shake things up a bit in my discipline. So.
Well, and I think that brings up a really great point, though, that it's kind of wide open to try new techniques. It isn't 100% solid. This is how you're going to do it every time. And I would guess that's one of the reasons that make this interesting, is that there are going to be lots of new ways you're going to have to approach it. Maybe it's not different every time, but it evolves, and it's not a static business of this messier data. And Leif, we've been talking, using AI or large language models to help with data. Do you see that being a place you could implement, or have you implemented that before with the data sets that you're dealing with?
Yeah, I mean, the trend right now is machine learning for model development versus the like multilinear regression or something like that. And that does seem to work, it does improve the modeling. It's very, we have, we're working with trying to get very large data sets. So we have lots of variation in geography and also in water quality types. And so working with the large data sets, the machine learning is definitely, kind of making, headways and making some really nice data products at the end. So we're working on trying to figure out the best way to do that right now. So we don't have the exact answer, but all the results look really promising. Especially like chlorophyll was one with the multilinear regression. It tended to overestimate the really clear waters. So the lower chlorophyll levels, were kind of overrepresented, or they said it was a lot higher. So being able to get a good handle on those really low chlorophyll where there's not much in the water, so there's not much to model. The machine learning tends to do a much better job of that than the multilinear regression stuff we've done in the past. So
is there a role for the AI in the before we actually collect the data? And I'm thinking about like how you design maybe the experiment, or how maybe we even train people to go out there. Is that something that's been thought of like I don't know, prep on how to get this data before it gets to you, so it's not so varied and it's maybe a little more consistent?
Yeah. I guess since I don't really organize all that data, I kind of
right.
let other people do that. I wouldn't be the one to ask, but that maybe, I think the ones that seem to have a, good management programs seem to have pretty consistent data. And so, but there are many of them. Probably a national organization that would have consistent standards might be a better approach, so it's not, because if everyone's doing their own thing, it just it's going to be messy no matter what you do.
Right. And I get that. We unfortunately, as I used to tell my children when they were in their toddler range, you get what you get and you don't throw a fit. And you guys get what you get.
Yep.
You don't always get to say, I'd like this to be real pretty and I want it to look, like consistent, and how we use particular pieces of software, how we're going to actually be able to extract it out. You kind of have to get what you get. What do you see, Sreya? Do you see AI being used more, or how are we going to start to use this new tool? And I really think that our students, I feel like in some ways they're more familiar with it than we are. Not that they've had more experience, but I think they're already using it as a tool. And how do you see this tool being used in the future?
I think like that would in the picture initial, like before, we didn't have that, collected lots and lots and lots of data. So now we have so much data that everyone wants to do something with it, and that's when the AI came in. And now everyone wants to just implement AI models to every data that they have. But I remember one of my professor telling me that he was an AI professor actually, and he was telling me that even though you have lots of data and different AI models, you should only apply it when there's necessity. Like you shouldn't just apply it because you have data and you know a model. So you need to only apply it when it's actually necessary to do it. So I think that's really important, because AI looks cool. Even I like AI, but do you really you need to ask this question to yourself: do you actually need AI for this experiment, or can you just use other statistical models or other simple mathematical models to just get through it? So I think that's really like important questions, especially for students, because it, like when I was a student, even I was super excited to just like apply AI models everywhere. But I think that's an important question to ask yourself before you actually apply for it.
Well, when you have a new tool, as they say, if you have a hammer, everything looks like a nail. And if you
Yeah.
have this new tool, everything looks like a chance to use it. And I think that we probably should at least try to use it. But there's a real problem of overusing the newest technique. And Laurie, I feel like I cut you off a little bit early when we were talking about it. How do you think that it's going to dovetail into what you do? And is it maybe everything looks like a nail, and we need to maybe move a little slower with it and not overuse it? Or do you see it being really a new technique that opens everything up?
Oh, that's a great question. And, I feel like it's a little different in sociology and some of the more traditional social science disciplines, because I think we still really lean on our kind of established methodologies, and it is really unusual to encounter kind of unconventional methodologies in sociology. That said, I think I mentioned something about, media analysis. I think there's so many opportunities for using AI with understanding kind of our public rhetoric in the media, and how that intersects with whichever topic area you're interested in. And so that's very difficult to do without, some more modeled or potentially machine learning approaches. So AI could be super helpful in that sense, I think, being able to look at large amounts of media data. But
Almost more
yeah,
scraping. Is that what you mean? Like
yeah,
kind of
I
like
think
scraping the
scraping
data
is done
from
to some extent, yeah, but then being able to analyze that more and on a larger scale would be really compelling. I did want to add too to, Shreya's points about not using it when you don't have to. I also kind of want to like caution against using it or any tools as a reason not to dig into the data. I encourage anyone who's starting to work with messy or clean data sets to just get really familiar with the data. It's really easy to misinterpret your findings if you're not really, just make lots of graphs, try and understand what's happening, what units are being used. And the more familiar you get with your specific data sets, the less likely you are to kind of be taken down the wrong track. And I think that to me is like one concern I have about using AI or ChatGPT or any of those for the analysis portion, is that if you're not getting familiar with your data yourself, then I think you're really at risk for kind of spurious findings or something. So I think again, yeah, a tool, is it the right hammer, or is it a hammer, or is it a saw, but don't use it as a shortcut, I suppose, to really understanding the data that you're working with.
Well, I'd like to just continue our metaphor that we started with. You need to get your feet wet, because if you don't get in the middle of it, you don't know, you can't have a good sense of when you are getting nefarious data or how you're going to deal with it if you're kind of offloading it all the time and it's being altered before it ever gets to you. I completely see your point there. It makes me think that every one of you have really had time to get familiar with the data. So whatever data set you're playing with, that's exactly what it sounds like you have to do. You have to go out there and play with the data, see what it looks like, understand it, and not just be some numbers on a page, but actually tell a story. It's going to tell you something, and you can pull that story out. And if you have these intermediaries, it may help you tell the story, but it sounds like we also don't want it to be the author. In the end, we're the people who take that data and tell the story that we need to tell, whether it's in social science or if it's in medicine or in remote sensing of water data. Guys, I know it's a little bit early, but I also know that Leif is going to be on another webinar you're hosting right after this in about 9 minutes. So I don't want to go too far. I don't know if we have any, closing statements that you guys want to leave our students with about, where to go and like how to get familiar with these techniques that you're talking about. I kind of just want to give you like a minute each to like, where do you go next? How do you get familiar? What are your next steps to be able to be resilient and get familiar with these techniques we're talking about today? I'll start out with Laurie because we were together there, and we'll go to Sreya and Leif. I'll let you have the closing remarks there.
That's a really, great question. And I think I would suggest to students or kind of any early career folks who are interested in data science or working with big data for research first is, there's a lot of data already out there. And I really encourage folks who are still kind of developing their skills to try and find existing data. And anyone who's working with kind of social science information or even adjacent to that has a tendency to want to go out and collect more data. But I think, reach out to your connections in your network and find what data is already out there, because there's so much that's been collected and hasn't been analyzed. And I think we always need more help kind of understanding the intricacies of the social data that's already existing. And that can provide shortcuts for you and give you a chance to really, like I said, dig in, get to know some data sets, and then kind of see what you like about existing data sets, what you don't, that could kind of inform future data collection for yourself as well. So that's sort of my off the cuff recommendation. So,
completely understand. Laurie. Sreya, what are you thinking?
As much as I'd like to emphasize the importance of like knowing and learning high-tech languages, I think it's very crucial to like like knowing the subject or the domain that you're working, whether it's like biology, sociology, or like other stuff. Try to have basic foundations of your subject. This will not only like guide your research, but also will like help you ask the right questions so that you can interpret the data more effectively. And then comes the coding part. Then you can deal with learning all like analytical stuff and like mathematical stuff and like all these data, like high tech data science languages. And another thing for students who think that who started off recently, that and they're not actually doing these like high tech model, they're not already implementing these models. I think it's very also like it's very important to understand that the world of data science, it's very much, you can compare it to like a life of a chef. So because 80% of data scientists actually spend their time meticulously on just working and preparing the data, and then the 15% is to make, decide what technique they want to apply, and then the 5% is actually applying the technique. So students are worried about not already using these models and not already implementing these models need not to worry, because it's fine. You just need to know your subject. You just need to have strong subject knowledge, and then comes the data part. Don't worry about that.
These are great pieces of advice so far. I mean, finding volunteering opportunities, other places are using and need people to look this data over to get familiar. But knowing your stuff, I mean, we heard Leif talk earlier about chlorophyll, about Secchi discs. If you're just getting data, but you don't understand what that data is used for, if you don't understand what instruments are being used to collect that data, then how could you how could you possibly understand how to process it? We have a real quick question from Shifra. Shifra, do you want to unmute and ask, please?
Yeah, thanks, JD. Previous
Hi.
host of one of the webinars on science communication here, so really excited to be at another one. And thank you all for sharing your experience and your expertise with us. So my question is kind of going off a lot of the points that you discussed. And as Sreya just mentioned, so much of our work in data is all about cleaning and preparing data. And to me, if I can start my project, that's already a win. Like if I'm at the point where I can start my analysis, that we've already won, So I wanted to ask you about the future of AI and data with regard to using synthetic data in research, because we see that so much of the heavy lifting and the cost and the time of all of these data projects, it's really about the data collection and about the research methods, right? And I've only worked in industry. I'm fascinated by research and so interested in what a lot of you guys do. But what do you think the future is there for AI and synthetic data to kind of jumpstart research and new discoveries?
That's a great question. I'm going to open up to my panel. Anybody that wants to get in there. And Leif, I understand that your clock is clicking, and if the ticking clock hits too hard, we'll understand if you have to bow out.
Yeah, I think I guess the one point I want to make is, with the machine learning, is overfitting is a very important thing to be aware of, and having really good validation and test data sets besides just the calibration data sets, very important. If you are doing machine learning, you need very large data sets, not a few hundred. You need thousands, tens of thousands of data points to make a good model, especially for something like water quality, which is very variable. Lots of different things in the water, and so really having large data sets is very important. And doing strong models, but simple models is always good too. Keeping things simple, so you're not having a very complex model when you really don't need it. I thought that was a very good point. But yeah, then I guess the for the synthetic data, I'm not sure how if your synthetic data is representing real data, great. If it's not, then you're doing you're not going to be, making any progress because you're going to be making assumptions that aren't necessarily reality. So having real data, I think, is more important than synthetic data, but that's me. I haven't worked with a lot of synthetic data, so I'm not sure about that one.
Any other comments about the synthetic data? I would like to hear.
I think Leif mentioned like obviously real data is more like significant than synthetic data, but even in general like machine learning models, a lot of researchers do use some synthetic methods. Like I can think of one synthetic method that's called SMART, that basically is called like synthetic minority oversampling technique, that basically that generates synthetic data to kind of balance the samples. Like if there's a majority class and a minority class, it kind of this technique, by implementing this technique, it kind of balances so that both of them get like both of them now are equal classes. So I think researchers are already using this techniques, but but also along with the real data. I don't know if researchers just use the synthetic data. I hope that answers the question.
I really appreciate that. I know we're coming upon the hour. I want to give Leif that full minute to prepare for his next one. I completely wish I could continue this conversation more. I feel like we have more in us, but it always has to end at some point in time. I appreciate, again, all of you being here and lending me your expertise. This has been a great conversation, and I will see you in the cyber web someday or somewhere else. Thank you
Thanks
very
a lot.
much,
Thank you all
guys.
for having us. Thanks for being here.